skip B. So the warm-ups at the top of our notes today ask us to solve by factoring. And when we're solving, that means we should be getting actual answers, not just parentheses binomials. So what would be the first thing I have to do to solve number 1? Move stuff over to the left side. So we would add our x and subtract our 6. And then we solve by factoring. So we factor into our 2 binomials. What would our 2 binomials be? X plus 3 and x minus 2. Good. 3 times a negative 2 is a negative 6. 3 plus a negative 2 is a positive 1. And then we would, since it says solve, use our zero product property to get our 2 answers, which would be negative 3 and positive 2. We'll skip over B. For number 3, same thing, we need to get it in standard form, so move over your 3. Now, why is this a harder factoring question? Because there's a 2 in front of the x squared. So this is your guess and check, although this one isn't very hard, because the numbers are small. So this has to be 2x and 1x. Those are your only options. No guessing there. And then the other numbers are 3 and 1. You just have to figure out where they go. If you put the 3 here, you're going to get 6 minus 1, which isn't going to get you 1. So we'll put the 3 in the other spot. And so we will get 3x and 2x. Now you have to figure out where the positive and negative goes. The positive would go with the 3, and the negative would go with the 1. And then we use our zero product property again to set each of these equal to 0. And we will get negative 3/2 or negative 1.5. And the other one will get a positive 1. What are those here?
These are my cards for my vocab test.
They look like CBT slips. Or, like...
Please excuse interruption. At this time, boys basketball is now dismissed. Again, boys basketball is now dismissed. Thank you.
Okay. What we're going to do today, guys, we're going to solve radical equations. So instead of having quadratics, we'll have square roots, cube roots, something to the 1/3 power. A radical equation is an equation that has a variable that is in the radicand, which means underneath the radical. Or it could also be a fractional exponent, like x plus 3 to the 1/2 power, because that would be a square root. Okay? So, steps to solve a radical equation are, step 1, isolate the radical on one side, and then you will raise both sides of the equation to the appropriate power to cancel something out. So if you have a square root, we'll square it to undo the square root. If you have a cube root, we'll cube it. Okay? And then you'll solve, and you do want to check your answers because you can sometimes get extraneous answers, especially when you have variables on both sides. So you do have to check them by plugging them back in. So for number 1, the first thing we would do is get the radical by itself. So I need to add 6 to both sides. Normally, we want everything set equal to 0 for quadratics, but with radicals, we actually need to isolate the radical itself. And now we are going to raise both sides to the appropriate power to undo whatever radical we see. So we will square them. The square and the square root just fall away. We're left with the radicand, 5x plus 1, equals 36. Subtract 1, divide by 5, we have our answer. Now we do have to check it. So we'll have the square root of 5 times 7 plus 1 minus 6 equals 0. 5 times 7 is 35. 35 plus 1 is 36. The square root of 36 is 6. And we will get 0. Okay, you could probably check it mentally just by plugging it back in your head. But if you want, show the check. What would I do first in example 2? Mason?
Add 10.
Add 10. Very good. we have negative 5 plus 10, which would be a positive 5. And solve by squaring both sides. Some students will forget to square the 5. We'll square the left-hand side, but they forget to square the right-hand side. And then we just subtract and divide. When you check it, you do again want to check it back in the original, not the one that we moved stuff around in. You'll see why on the back. We should have negative 10 plus the square root of 2 times 12 plus 1. Does that equal negative 5? And this will be 24 plus 1, which is 25. The square root of 25 is 5. And we will get that negative 5 is equal to negative 5. Okay, we have a word problem, everyone's favorite, especially the volume one on our last test. So this one is talking about the power P in watts that a circular solar cell produces with the radius of the cell in centimeters are related by the square root equation. R equals the square root of P divided by 0.02 pi. How much power is produced by a cell with a radius of 20? Well, R is the radius, so we need to plug 20 in for R. So this isn't really a word problem. It's a problem that has words, but realistically we didn't have to do much except plug a number in, and then it becomes just a solving. So see if you guys can solve this for P. Start by squaring both sides to undo your square root. You don't have to rationalize the denominator, so make sure you don't do that. It just asks you to solve. So see if you can square both sides and get an answer, and we will round to the nearest tenth. To undo division with multiplication, and that will get me 8 pi equals P. And then you can type 8 pi in your calculator using the pi key, or 3.14. Pi key is more accurate. So on the back, we're going to see equations that have, instead of square roots or cube roots, we could see rational exponents. So the problems are really the same. You want to isolate the variable that's being raised to a power on one side of your equation by using inverse operations to move everything to the other side. And then you're going to raise both sides of the equation to the reciprocal power. So if it's right now being raised to the 2/3 power, you would then raise it to the 3/2. And then that way, they end up undoing one another and you're left with the first power. So you don't have any exponents left. Okay? Remember, whatever you do to one side, you'll have to do to the other. And I have this here with variables. And then step 3 is, of course, to solve and check. Now, you want to remember that if you have an even root with a positive number, for example, the square root of 4 is technically positive and negative 2. So sometimes you will get more than one answer to the problem because of that fact. If it is an odd root, you do not attach a plus or minus. So like the cube root of 8 is just 2, not plus or minus 2. So we'd only get one answer. All right, example 4. First, we're going to isolate the variable. So we'll divide both sides by 2. To get x plus 3 to the 3/2 power equals 27. Now we're going to raise both sides, usually I'll put brackets around them, since I already have parentheses, to the reciprocal power, which would be our 2/3 power. So that these, again, will divide out, or get you 6/6, which is then just 1, so this is just x plus 3. Now, what is 27 to the 2/3 power? Well, you can use your calculator to type it in, if you want to, but we can do this by hand. The index is the denominator, so this would be the cube root of 27 quantity squared. The cube root of 27 is 3, just 3, not positive or negative 3, just 3. And then we would perform 3 squared, which is 9. Subtract 3 on both sides, and we'll get x equals 6. And then to check that, you can plug it back in. We can show the check on our calculator too if you want. So you could do 2 parentheses, 6 plus 3, close parentheses. Now when you type in rational exponents, you do have to use the caret button and parentheses. So 3 divided by 2. And we better get 54. We do. So it checks. The next one. What would I do first in this problem? Lindsay? Say again? Plus 5? And? Lindsay? Divide by 4. You have to isolate the variable that's being raised to whatever power. We'll have x to the 2/3 power equals 4. Now we raise both sides to the reciprocal power, which would be the 3/2 power. Now, if you type this in your calculator, it will only give you one of the answers, not both of them, so just be aware of that. When we type in the square root of 16, it only tells you 4 in your calculator. Technically, it's positive and negative 4. So be careful. Okay? So a lot of you will lose an answer right here. So this is the square root of 4 quantity cubed. Right? So the square root of 4 is positive and negative 2 cubed. Which technically, positive 2 cubed gets you a positive 8. Negative 2 cubed will get you a negative 8. So this would be a plus or minus 8. So technically you have 2 answers. One is positive 8 and one is negative 8. You're welcome to just leave it as plus or minus, but this one does get you 2 answers. And we can check them both back in our original. And again, just due to time, I'll show it on the calculator. So we'd have our 4. To plug in an x value, I would use parentheses. So we'd have 8 caret to the 2/3 power minus 5 equals 11. So you're always checking it back in the original one, not the one you modified. And then if I want to retype this all over, just press second enter. I can arrow back to my 8. And I'm going to have to insert, so you press second delete, see the little insert, and you can put the negative sign in front of it without having to retype everything. And we get 11 also, so they both check. Do you think you're ready to try the next 2 on your own? Or do you want to do one more? Do it on your own? Okay, try 6 and 7, we'll get 2 of you to the board. Okay, so again, on the homework online, make sure you only do numbers 1 to 14. Because all of them are in one document this time for some reason. So 1 to 14 only.